Welcome, Math 1111ers, to Lecture 3.3, the next to the last lecture for this semester. I can't believe that we are already here. I'm going to go ahead and get started on the material for you. So the main thing we'll be getting out of this section are properties of logarithms. So it's really important that you know your exponent properties because, as we've seen with the previous material in this chapter, exponents and logarithms are inverse operations of each other. Our exponential functions and logarithmic functions are inverse functions of each other. And so if you know your exponent properties, then these logarithmic properties shouldn't be a stretch or too much of a stretch for you to understand. So that's what I'll be focusing on today. We'll get the product property, the quotient property, the power property, and then the change of base formula. So let's go ahead. I want to start out again this particular section with just going back to our definition, because as usual, if you can wrap your brain around this definition, then you shouldn't have any trouble with these properties and things like that. So once again, if b to the y is x, then log base b of x is y. And whenever I teach this, I always point out to go from logarithmic to exponential, you start at the base, raise to the is, and that equals the of. So let's go ahead and take a look at these first three rules, and then we'll work on expanding and condensing logarithms using these rules. So first of all, before I go through these rules, I want to establish an example with you because I'm going to use this example to show that these rules actually work. Now, this is not a proof that these rules work. It's just an example. Mathematical proof is a different beast, and I fear that I would lose many of y'all if I started proving these things to you. But an example always helps, like a number example will help us to see that yes, these rules do work. So let's first start out with the main example of log base 2 of 16. And this is asking what can I raise to get 16, and the answer here is 4. So if we can keep that in mind when I give examples of these next rules, you'll see how we're going to get 4 for different forms of log base 2 of 16, no matter what rule we're using here. So the first rule with logarithms is the product rule. Now let me remind you that when you're multiplying like bases, x to the m times x to the n, that you add the exponents, x to the n plus n. So the corresponding logarithmic rule says when I'm taking the log of a product, I can expand that into log of the same base of each of the factors and add them. Log base b of m plus log base b of n is the same exact thing as log base b of m times n. So let me go back to our little example that we started out with and show you that it works. Once again, this is not a proof, it's just an example. So once again, log base 2 of 16 is 4. I could rewrite log base 2 of 16 as perhaps log base 2 of 2 times 8, some product there. And if I use the rule and expand this, I would have log base 2 of 2 plus log base 2 of 8 Log base 2 of 2 says, what do I have to raise 2 to get 2? And that's 1. And log base 2 of 8, what do I raise 2 to get 8? That is 3, because 2 cubed is 8. 1 plus 3 is 4. Same exact thing if I had just taken log base 2 of 16. Next rule. Since this is the quotient rule, let me just remind you, whenever you have a quotient of like bases, you subtract the exponents, and it's numerator minus denominator happening in the numerator. So the corresponding logarithmic rule says if I'm taking the log of a quotient, that's the same exact thing as taking the log of that base of the numerator minus of that same base of the denominator. An example. Using our log work from, an example might be log base 2 of 32. My pen keeps freezing. 32 over 2. So 32 divided by 2 is 16, so we know that this needs to be 4. If we use the rule, this says log base 2 of 32 minus log base 2 of 2. Log base 2 of 32 is 5. Log base 2 of 2 is 1. 5 minus 1 is 4. All right, the power rule. You should remember from your exponent rules that when you raise a power to another power, you multiply the exponent. So x to the m times n is x to the m, x to the m raised to the nth power is x to the m times n. So you multiply. The logarithmic rule says when I am raising the log that I'm taking to an exponent, that exponent comes out front and multiplies with the logarithm. So I have p times log base b of m. And I will give you an example. So if I have log base 2 of 16 is the same thing as 4 squared. Okay, that has to be the same thing as if I bring that exponent out front and multiply, so 2 times the log base 2 of 4. Log base 2 of 4 says, what can I raise 2 to make 4? And that's 2. So I have the 2 out front being multiplied with log base 2 of 4, which is 2. 2 times 2 is 4. And I could have used infinitely many examples to show you those rules. Log base 2 is just easy to think about and work in. We're familiar with the twosies. So let's move forward. Okay, so what does it mean to expand a logarithm? It means to change the log of any product to addition. It means to change the log of any quotient to subtraction. And it also means that the log of any base raised to a power, that power comes out front and multiplies as the coefficient in front of the log. So you don't want to leave, and also if anything can be evaluated, it needs to be evaluated. We'll see examples of that here coming up. So you just want to expand everything out that you can. So I'm just going to move through 5 examples to help you understand this process better. So just like when we were just evaluating logarithms in the last section, I told you anytime you have a root, you want to change it to a rational exponent. Just to remind you of that rule, anything raised to a rational exponent, m over n, is the same exact thing as taking the nth root of a to the nth power. So an example there, x to the 1/2 is the same exact thing as the square root of x, because there is an understood 2 index and an understood 1 that that variable is being raised to, or that the radicand is being raised to. So coming back here, log base b of this product x to the 4th cube root y. Well, the first thing I'm going to do is get rid of that root, so and change it to a rational exponent. Log base b of x to the 4th, y to the 1/3 power, since I'm taking a cube root. And now I have that product that I want to expand out with addition. So log base b of x to the 4th plus log base b of y to the 1/3. And then the last thing that I need to deal with are the powers, and they will both come out front as coefficients. So my final form, my final expanded form here is 4 log base b of x plus 1/3 log base b of y. And I'll just put these in parentheses showing that's what we're taking the log of. And that's it for that one. Okay, so this next one, log base 5 of the square root of x over 25y cubed. Let me just say there are going to be a number of ways to go about expanding these things. It's kind of what you see first to do. So some of you, pardon me. Some of you may choose to bring that 25 up and make it, or actually, I'm sorry, some of you may choose to turn that 25 into a 5 squared and then bring it up into the numerator and give it a negative exponent. Some of you may choose to leave it the way it is and just subtract it. So it's really whatever you see, and you're going to end up with the same thing, and no matter what you see to do, as long as you're following your exponent rules and your logarithmic rules. So first thing I'm going to do is get rid of that root, and then I think I'm going to go ahead and change 25 to 5 squared, because I can write it as an exponent of the same base of the logarithm that I'm taking. I just always think it's a good idea to do that when you can. It tends to simplify things in my brain, so that's what I would suggest. All right, so log base 5 of x to the 1/2 divided by, let me go ahead and write that as 5 squared. 25 is a power of 5, so 5 squared, y cubed. Sorry, my pen keeps freezing on me. All right. Now I want to separate the numerator from the denominator. So I'm going to subtract the denominator, the logarithm of the denominator, from the logarithm of the numerator. So this is the same thing as log base 5 of x to the 1/2 Okay, I'm going to turn my video off just to see if that helps with my pen freezing. So, sorry, bye. Not that you're that torn up that I'm turning my video off. All right. So that is log base 5 of x to the 1/2 minus the entire denominator of log base 5 of 5 squared times y cubed. So it's the log base 5 of that whole thing. And I'm just using brackets to hold that logarithm together. All right. So the next thing I can do is I can go ahead and bring that 1/2 out front as the coefficient, and then I want to split this product up on the inside of the brackets into addition. Expand it out. So I have 1/2 log base 5 of x minus, still in brackets, log base 5 of 5 squared plus log base 5 of y cubed. Okay, I can still expand more by bringing this square out front here and this cube out front as the coefficient there. So here's where I am so far. 1/2 log base 5 of x minus 2 log base 5 of 5 plus 3 log base 5, oops, just a second, I didn't mean to put the parenthesis there, log base 5 of y in bracket. I'm still not done yet because I can evaluate log base 5 of 5. I can actually get a number there. And that's 1. That whole thing becomes 1, log base 5 of 5. However, I'm multiplying the 1 that this turns into with the 2. And then I can distribute that negative to both the terms. So my completely expanded version of this logarithm is 1/2 log base 5 of x minus 2 minus 3 log base 5 of y. Okay, so let me just go back and point out what my final logarithms are. So for this first one, A, this is what I end with, completely expanded. And B, I end with that, completely expanded. All right, I have 3 more examples of expansion to go through for you. So let me go back to my black pen. All right, so we have a lot happening in this next one. And don't forget that the ln is just understood to be log base e. That's the natural log. So I have ln. The first thing I'm going to do is split numerator and denominator. I have the ln of x to the 4th, and then I'm also going to change that root into a rational exponent. Let me actually use a bracket here, because now I have x squared plus 3 to the 1/2 in the bracket. That's all in the numerator. And I subtract the ln of x plus 3 to the 5th. Okay? So in my next step, I'm going to split this product in the numerator up right here into addition. And I'm also, I guess I'll go ahead and pull this 5 out front as the coefficient here. All right, so I have ln of x to the 4th plus the ln of x squared plus 3 to the 1/2 minus the ln, oops, I meant to do 5 ln. I'll do it on the next step, x plus 3 to the 5th. Yeah, now I'll bring all those powers down as coefficients. So the 4 comes out front there, the 1/2 comes out front here, and the 5 comes out front there. All right, so I have the 4 ln of x plus 1/2 ln of x squared plus 3 minus 5 ln of x plus 3. And that's all the expansion that I can do in that one. There's no coefficient that gets distributed or anything. So I'm completely expanded here. All right, the ln of the square root of ex. So the first thing I'm going to do is change that square root to ex raised to the 1/2. Notice both the e and the x are being raised to the 1/2. So before I split them apart, I'm going to go ahead and pull that 1/2 out as the coefficient on both of them. So my next step looks like this. 1/2 ln of ex. Now I'm ready to break that product into addition. So I still have the 1/2. And now I'm going to use brackets here because now I have the ln of e plus the ln of x. Well, hopefully it jumped out at you that the ln of e can be completely evaluated as just 1. ln of e is 1. So then I can distribute that 1/2 to both of those terms, and I end up with, so that's 1/2 times 1, just 1/2, and 1/2 times the ln of x is plus 1/2 ln of x. So that one wasn't so bad. But notice that you do have to evaluate and get a number answer when you can. So watch out for ln of e, watch out for log of 10 or log of powers of 10 or ln of powers of e, and log of any base where that base is raised to some, that same base is raised to some power. You'll be able to evaluate it further. All right. So this last one for expansion, I have the cube root of the log base b of cube root of x, y to the 4th, not under the cube root, z to the 5th. So this is the same thing as log base b of x to the 1/3, y to the 4th, over z to the 5th. Okay, so I'm going to split numerator and denominator now. Log base b of x to the 1/3, y to the 4th, minus log base b of z to the 5th. Now I'm going to split that first term up, the product, into addition. So log base b of x to the 1/3 plus log base b of y to the 4th. Oops, it's a minus. Okay. Minus log base b of z to the 5th. Now the only thing I have left to do is to pull the powers down and bring them out as coefficients on the logarithm. I don't have any evaluating that I can do with this one. So log, it's 1/3 log base b of x plus 4 log base b of y minus 5 log base b of z. And that is my expanded logarithm there. Okay. Now, the next couple of pages have us moving in the exact reverse. So you start out with this expanded logarithm and you condense it or pack it all back into one log. So you're using all of these rules in reverse. So instead of writing go from addition to multiplication, blah, 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 I'm just going to say pack it back into one log. All right. So the first thing that jumps out at me in A here is that these coefficients need to go back up into the exponent. So I have log of x to the 1/2 plus log of x minus 1 to the 4th. And x to the 1/2 is really a square root. So that's log of the square root of x plus log of x minus 1 to the 4th. And since it was addition here, that means it came from the log of a product. So we end with the log of square root of x. I'm going to use brackets here since I'm going to have parentheses, times x minus 1 to the 4th, the log of that whole thing. And we're packed back into one logarithm. So that's what I end with when I'm condensing. The exact opposite of expanding. All right. So in this next one, I see another coefficient that needs to go up. And then I'll have the subtraction to deal with after that. So this is ln of x plus 7 cubed minus ln of x. Well, if these logarithms of the same base are subtracted, that means they came from one logarithm that had division. So this is ln of x plus 7 cubed divided by x. And it's the logarithm of this whole thing, or the natural log of that whole thing. Okay, C. I'm going to bring these back up first. Which puts me here. Have log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2. Okay. Condensing even further, log base b of x to the 4th minus log base b of 36 minus log base b of the square root of y. Now I've got double subtraction that I can factor out, which would leave me with log base b of x to the 4th minus the quantity log base b of 36 plus log base b of the square root of y. So inside my brackets, I can turn that back into multiplication. So log base b of x to the 4th minus, packing it back into one logarithm, log base b of 36 square root y. And subtraction turns back into division of the same log. Log base b of x to the 4th over 36 square root y. And that's it. Packed back into one logarithm. All right. 3 more examples, or 2 more examples. So did I already have 3? Oh, yep, I forgot to edit that one. There we go. 2 more examples of condensing, and then we'll move to change of base, and that's it for this lesson. So not too bad. Okay, so the first thing that I see that I need to deal with are these coefficients needing to go back to the exponent where they came from. Okay, so now I have ln of x plus 6 to the 4th minus ln of x cubed. And since I subtracted these natural logs, they came from being divided. So this is the ln of x plus 6 to the 4th over x, the ln of this whole thing, x cubed. Okay, so let me point something out that was brought up in my class earlier today. One of the students said, I got the same thing you got, but I put ln of x plus 6 to the 4th over ln of x cubed, and that is incorrect. Let me give you an example that shows you that that's 2 different things. Taking the log of a quotient is different than taking the log of the numerator divided by the log of the denominator. So let's consider the common log of 100. So the log of 100, and that's log understood base 10. That's what do I raise 10 to make 100? So we know that that's 2. The log of 100 is 2. If I do the log of, let's say, 1,000 divided by 10. So the log of 1,000 divided by 10, that's really the log of 100. So we know this needs to come out as 2. We'll use our rules to show that that is the same thing as the log of 1,000 minus the log of 10, which is 3 minus 1 or 2. Now, if I do the log of 1,000 divided by the log of 10, log of 1,000 is 3, log of 10 is 1, 3 divided by 1 is 3. So you don't get an equal quotient there. So please be very careful and realize that the log of a quotient is different from taking the log of the numerator divided by the log of the denominator. This concept right here has everything to do with what we're about to talk about on the next page, which is change of base. So just please be very careful about that. Okay, so I'm going to put that 1/2. I'm sorry, I'm not going to do that first because I've got stuff on the inside that can go back together first before I put that 1/2 back into the exponent. So the first thing I'm going to do is change that addition into multiplication with the same log, and I will put this 2 back on back into the exponent in that second term. So I have 1/2 times log base 5 of xy. These brackets. Minus log base 5 of x plus 1 squared. Okay, so now I can put the 1/2 back into the exponent, which it just takes the square root of xy there. So I'm not going to do that in 2 separate steps. So this is the same thing as the log base 5 of the square root of xy minus log base 5 of x plus 1 squared. And since I have subtraction, that came from the log of the quotient. So log base 5 of square root of xy over x plus 1 squared. It's the log of this whole thing there. And let me just note my final condensed logarithms here. We've got that there, and this one here. All right. That's it for expanding and condensing. Now let's take a look at our change of base property. This is what allows us to do any logarithm in our calculator. Your calculator only works in base 10, common log, and base E, natural log. Let me go grab my calculator real quick. Okay. All right, so the rule for change of base, or the change of base property, says that log base b of m is the same exact thing as taking the log of m, so the common log, over the log of b, which is the same exact thing as taking the ln of m over the ln of b. Okay, so I'll just show you real quick how that works off to the side here. So we start out with log base b of m equaling something. So I'll just put a question mark there. If I change this into exponential form, I have b to the question mark equals m. And then if I take the log of both sides, let me get a different color to do that. If I take the log of both sides, we have this, And then when I take the log of both sides, I'm now free to bring question mark out front as a coefficient. So question mark, I'm going to try to keep this color-coded so you can see where everything went. Log of B equals log of M and if I want to solve for question mark, then I would divide the log of B off both sides. And I end up with question mark equals log of M divided by the log of B. And I could have used ln just as easily. So that's why or how this change of base formula works. So when you're faced with something like log base 5 of 13, well, you could certainly estimate it. 5 to the first power is 5. 5 squared is 25. So log base 5 of 13 is somewhere between 1 and 2, but we want to be exact. So we use our change of base formula to say this has to be the same thing as the log of 13 divided by the log of 5. We could have said ln of 13 divided by ln of 5. It's the same exact thing. So I'm just going to put this into my calculator. Log of 5, be careful, make sure you close your parentheses, divided by log of 13 divided by log of 5. And when you are giving these answers, make sure you use the approximation symbol because you're going to have to round. I'm going to round to the 4th decimal place, so 1.5937. And this next one, I just put into my calculator, log of 87.5 divided by log of 14, and get approximately log of 87.5 divided by log of 14. I get approximately 1.6944. Okay, I'm going to use the ln for these last two. You're going to get the same exact answer, I promise. You can try it both ways in your calculators. So ln of 17 over ln of 0.01. ln 17 divided by ln 0.01, and I get approximately, around, negative 0.6152. And this final one, the only thing I'm going to caution you against, you have log base pi. Use your pi key. Don't round to 3.14 because that's creating more round off error. So ln of 400 divided by the ln of pi is approximately ln of 400 divided by, your pi key is the second function on your caret function. Your caret function is the thing that looks like that raises into the exponent. If you look closely, the second function on your calculator is pi. So I do second caret to get the pi value. So ln of pi, and I get approximately 5.2340 because it's 395, so that's all going to round up to 340, and I do need to write the 0 to show that I rounded to the 4th decimal place. Well, that's it for 3.3. Don't forget, you're going to have your last quiz opening up this Thursday. It will cover 3.1 through 3.4. It will be due Monday the 28th. Monday the 28th is when final exams start. If you have not registered for final exam, you need to do so immediately. Exam registration will close this Wednesday at 5 o'clock. If you have not registered by that time, you will not be allowed to take your final exam. So please do not miss that deadline, because I am not going to be giving special final exams for people that missed the registration deadline. You need to be responsible enough to make sure that you're registered for that. Next lecture, it's actually the last lecture material. I will do a quiz review on Wednesday, but the last new material is tomorrow. That's section 3.4 at 3 p.m. See you then. If you haven't registered for fall, go ahead and do so. Thanks.